for this lesson. And as we work through Unit 6 of Computer Science Principles, we are going to be talking about algorithms. We won't do everything in these lessons, so make sure you pay attention because some of it is going to go a little bit deeper than what I really want to go into. But we will start with how algorithms solve problems, and this is going to be lesson 1. This is linked in your assignment post. And so the first thing that I want you to do after you download the activity guide, this is the activity guide. Okay, it's looking like this. All right, you got your name. You'll make a copy, and we're going to go through this stuff. Okay. So the activity guide says to follow the prompts and complete the questions on the document. Be sure to do all 5 parts. So there are 5 parts. You do not have to do part 1. Okay? No part 1. You can start with part 2. If we were in the classroom, you would go around the room. You would have these 10 problems, right? You still have the 10 problems. They are on your activity guide. We would go around the room and write down our answers to these problems. Find a person whose birthday is before yours. So if my birthday is November 11, I would look for anybody whose birthday is from January 1 to November 10. Okay. Find a person whose birthday is after yours. I would look for somebody with a birthday from November 12 to December 31st. So I would literally go around and ask people these questions. When is your birthday? When is your birthday? Okay, when is your birthday? A lot of these are about birthdays. Let's look at, yeah, it's the same thing. Okay, so you can Google somebody if you want. You can use celebrities, pretend like you have celebrities in your class. Or if you're sitting in a physical classroom and you have people around you, you may be able to do this with them. So that is also an option. You just want to be able to find answers. So you can put your birthday right here. And then you can put whoever's name, like whoever you find for this first problem, you can put their name and then their birthday. And just go along this list until you have all of those questions answered. Okay, so pause the video until you get that done. And you can either write it on a piece of paper and submit a picture of that, or you can complete it on the activity guide, which might actually be easier. So pause the video so you can finish that. Now, with someone, share how you went about solving each of these problems. Which problems did you need to do something similar in order to solve them? You don't have to share this with somebody, but think about it. All right, you can add that to your activity guide, your response. Okay, you can put that. It's part number 3. Okay. Now, part number 4, decide which of these, so let's look. Okay, with your partner, decide which of these programs are the same as one another. So I'm going to help you kind of talk through these with you, okay? Algorithm 1 says move forward, turn right. Move forward, turn right. Move forward, turn right. Move forward, turn right. Okay, algorithm 2 says repeat 2 times. Move forward, turn right. Move forward, turn right. Algorithm 3 says moves forward, right, forward, right, forward, right, forward, right for each move in moves. If move equals F, move forward, else turn right. Okay? So this is saying it's going to count how many there are in this list. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to run through this 8 times. If move equals F, move forward, turn right. Or if move equals F, move forward. And then it's going to go back. If move equals F, it doesn't, it equals R. No, else turn right. Okay, so algorithm 3 is the same as algorithm 1. Okay, let's look at algorithm 4. Start, count is less than 0, or count is 0. If the count is less than 4, then it would be true. If it's false, then it's going to end. So that's 4. Move forward, turn right. Count equals count plus 1. Okay, this is also the same. So 1, 3, and 4 are the same. Okay. One, 3, and 4 are going to draw a square. They make a square. 2, 5, and 6 will make a rectangle, because you see how you have in algorithm 2 you have 2 move forwards together. So if I were to do this just on paper, I would say move forward, turn right, move forward, turn right, move forward, turn right, move forward. So we're moving forward 2 times here and only 1 time here. So all of the other, like algorithm 1, it's move forward, turn right, move forward, turn right, move forward, turn right, move forward, turn right. Okay, so it's 1, 3, and 4 make a square, and then 2, 5, and 6 are going to make a rectangle. All right, and you can see that because in 2, 5, and 6, there's always 2 move forwards together. So repeat 2 times, move forward, move forward, move forward. Okay, so some of these algorithms would turn a robot right by turning left 3 times. It's debatable whether we can really call these algorithms the same. Some of these algorithms create lists or variables to store information. Depending on the context, we may not be able to call these algorithms the same. They may accomplish the same objective, but they're not technically the same. So, our question was, which is the same? We want to look at how we decide which ones are the same. Okay, so we have the examples on your activity guide. You have algorithm 6, and you would put your response. I would put it either right here around part 4, or I would put it underneath algorithm 6. Okay. Now, for our wrap-up for this lesson, we've talked about 2 different things in this lesson. A problem, which is a general description of a task that can or cannot be solved with an algorithm, and an algorithm, which is a finite set of instructions that accomplish a task. So, there are usually many algorithms to solve the same problem and many ways to write or express one algorithm, including natural language, which is the way you speak, pseudocode, which is like natural language, except it's like when natural language and code come together, and it's like a list of instructions. Diagrams, which are what you see here, and are implemented using programming code. All algorithms can be created by combining steps in 3 different ways. So you have 3 different ways to implement an algorithm. You have sequencing, which puts them in order. You have selection, which is going to give you a condition. If it's true, do this. If it's false, do this. And then you have iteration, which is going to have a little bit of selection, but then it repeats. Iteration means repeat. I thought I'd be able to, okay. All right. So we are going to add these two definitions to our our key vocabulary. All right, and this is your final prompt. Let's double check. Okay. How did today's activities change the way you think about algorithms and problems? All right, so computer scientists don't just think about code. They think about problems and the algorithms that solve problems. In this unit 6, we're going to explore what makes 2 problems or 2 algorithms similar or different from one another, and the way computer scientists talk about them. Not only will you be a better programmer, but you'll also get to work on some really interesting problems along the way. So in your own words, you can put this at the very bottom of your activity guide. In your own words, I want you to explain the difference between a problem and an algorithm. And you actually, instead of putting it in your activity guide, on the assignment post, you can click the link to Unit 6, Bubble 1, and you can put that answer there.